Myself Peggy Ashrita, and these are my teammates G. Ashrita and Alokam Janvi, with our supervisor as Mr. Syed Fayaz sir, working on a project on current state of understanding the energy efficiency of cloud computing with resource utilization as a module. These are our industry details for the organization which we are currently working on. The name of our industry is Go for Hyperlocal Private Limited, and the duration is from 6 months. The name of our industry guide is Mr. Bharadwaj. So now comes to abstract. Cloud, as we know, cloud environment generate huge amount of data, and these data can be stored and processed at data center where data growth is exponential. So it is fundamental that they both have the technical infrastructure. In this project, an energy efficient scheduling algorithm in cloud is proposed to reduce the carbon emission at data center. The ultimate aim of the project is reducing the energy consumption, increasing the resource availability. The proposed algorithm reduces the carbon emission by load balancing the input jobs, and proper scheduling allows us to improve the resources availability, and it can be done by calculating the weight of server and then virtual machine allocation using the weight approximation algorithm based on the utilization evaluation. And later we will compare. The ultimate aim of this project is to analyze the area of energy consumption in data center, and here we are using the Cloud SIM technology. By using Cloud SIM, we can create the data center with one host and can run one or multiple cloudlets on it. It allows the users to test their services in a controllable environment. Our main objective of this project is to reduce the energy consumption and increase the resource availability. And the focus is to reduce the power consumption by identifying and terminating an idle host as well as the virtual machines. And then the performance of evaluation should be seen to show the better results when compared with the earlier resource allocation algorithms. As we know how resources are running data centers these days, which in turn require bulky infrastructure, huge space for servers, and also high pay and a team to manage these servers. So here comes a cloud computing concept which overcome all these factors, where we only pay for what we use and can access the data from anywhere around the world just via internet access. Cloud computing is the delivery of different services through internet, including data storage, server database, networking, and software. And cloud computing, as we know, is the most trending and highly confused concept these days, and it will also likely to continue for upcoming years as well. So many companies these days offer cloud services, including AWS, that is Amazon Web Services, Microsoft Azure, etc., due to its incredible rising demand. Now comes to literature review. We have several authors who have already pre-proposed systems. So the first one is Zhou. In 2018, worked on the project Virtual Machine Migration Algorithm for Energy Efficiency in Cloud Computing. And he proposed an algorithm named EEOM, that is Energy Efficiency Optimization of Virtual Machine Migrations. This algorithm optimizes the trigger time, virtual machine selection, and host location, taking the CPU and memory factors into consideration. And also we have several other authors who have their pre-proposed systems and the proposed algorithms as well. So now comes the design and methodologies. The initial step which we have to do is setting up of the cloud environment. Initially, we need to set up the cloud environment, for which we need cloud user request their application to execute in cloud by sending their application configurations, such as the number of cloudlet, application length, file input and output size. These requirements are sent to the cloud service provider such that global manager who allocates the resource to the cloud user. The experiment parameters which we require here is data center number of servers, which could be around 20 servers, and the number of ports that vary from 1 to 4, and also the other parameters as well. Once we set up the cloud environment, next step is to calculate the weight of a server. Here we will be calculating the weight of server to allocate the virtual machine in a server. And the formula which to calculate the weight of server we need is shown here. And also the parameters that are required to calculate the weight of servers is the frequency of ith host, available resource, allocated resource, and power usage effectiveness. These all parameters are required to calculate the weight of a server. Once the weight of a server is calculated, then comes virtual machine allocation using the weight approximation algorithm. So here, if the allocated size of a job is greater than the weight of first server, then we will be combining the first server and last server and assign the job on it. Or else, if the allocated size of job is less than the weight of first server, then we will compare the size of job with every other server to find the appropriate server. If none of the condition above satisfies, then we will assign the job to the first server. Once this process is done, we will be doing the utilization evolution based on power consumption. So the total physical energy consumption, that is PS, is calculated as P static plus P dynamic, where P static is the leakage of power of server and P dynamic is the dynamic power consumption. Once this process is also done, the final one comes is the comparison of power consumption. Total power consumption of servers is evaluated by applying the weighted approximation algorithm and comparing with the non-weighted server. If the power consumption is reduced, then the emission of carbon will significantly decrease.
As of now, Ashita has been explained what is our project. Now I will explain what is the implementation of our project and how it will be done. This is the architecture diagram of our project. The layered clouds in architecture consists of cloud servers, user source code, and simulation engine. The physical resources exist which power the data centers at the lowest layers, while the higher level virtualization services and toolkit servers are managed transparently. It allows the sharing of the capacity among virtual servers instances. This cloud sim layer manages the execution of the core entities during the period of simulation. The host of a cloud can be shared among the simulation and that execute user-defined QoS specifications. The user code is a topmost layer in the simulation stack that is used to expose configuration for hosts, virtual machines, and applications. The developer of cloud application generates and user request distributions, application configuration at this layer and later perform robust tests based on the cloud configuration. And this is the data flow diagram of our project. The process of generating cloud sim simulations means the simulation life cycle. It may be summarized into the following 8 steps. First is the initialization of cloud sim packages. There will be so many different packages, and then we can create a data centers and a broker creation, and we can generate a cloudlet and virtual machine, and we have to start the simulation. We have to stop the simulation. In the starting of simulation, automated process handled through discrete event simulation, and we can print the results. In each of these steps, we are visualized for the above diagram. Various components of the cloud architecture are have been integrated. And this is the data for this is the class diagram of our project. Here there will be 4 attributes. One is a data center, one is a virtual machine, and one is host, and one is cloudlet. The data center is then it models the service of core infrastructure offered by the resource provider. The set of computing hosts are encapsulated by either homogeneous or heterogeneous. Host it joins the physical machine information provided by the main memory, virtualization processing unit, network and so on. The information regarding the scheduling policies is provided in the class for controlling the processing unit and the virtual machine. It is in every component of virtual machine access to a component which stores the characteristics of memory, storage, etc., which is extracted from the virtual machine scheduling. And the cloudlet. It is a model of cloud-based application services that are deployed in data centers. It encapsulates the executed number of infrastructures to complete the task. And this is the input of the project. There are the different set of configurations, and there is a server and virtual machine. There will be tasks. By using this input, we will create a program by using Java. Now we can see the implementation. This is the conclusion of our project. The biggest challenge faced while attempting to reduce the data center's electrically consumption is to link data center activities to electrical use. Data center consumption is based on IT and infrastructure loads. Urban cooling systems remove heat from the data center to keep the temperature optimal. The main objective to tackle the heterogeneity of physical missions, varying execution times of virtual missions, the power consumed by each physical mission. It is clear from the performance results that the proposed algorithm works better than the traditional. First from Professor Raoud Roby, scheduled missions. This power consumed and the energy released can be directly reduced. More missions are able to complete their tasks in each faster time, ultimately minimizing the number of failed virtual missions. So some of the practical cases may not work as expected. Schedule based on this algorithm, we can reduce the energy consumption significantly. And then, what are the future enhancements of this project? Or there are a number of possible extensions to this project which could be performed if there is enough time. There are extensions that are not expected to be completed beyond even executing the minimum requirements and achieving all the started objectives. Extensions are this project. Here is the implementation of our project. First, we have to download a new version of CloudSim. I have now the new version is CloudSim 5.0, so I have downloaded that. We can run CloudSim by using an Eclipse IDE. In Eclipse IDE, I have an extension of Java developer, and now we have to I have create a Java project, and we have to export these file folders to the Eclipse IDE. Here we can see that a CloudSim folder and an examples of CloudSim and what are the packages. What is the main theme of this project is we have to create a data center with one host and we can run the cloudlet on it. So here we can see that first what we have to need. We have taken one example. Before that we have seen one input to that. So now we have taken one example for that and we have created a program by using a Java. Here not what is the addition of the new version is a container, addition of containers. Not only that, we have also added a GeoWeb packages and a plus packages to it. Now we will see an example to run a container packages and what are the input we have needed. So now we can see the program. First, we have to create one data center with one host and one cloudlet on it. So we have to create a main function for it first, and then we have to create one data center. Means in data center, we can provide any resources in CloudSim, so that we have to create data center. And into that data center, we have to create one broker to it. And means we have to create one ID. What is the broker ID to it? And then we have to create an virtual mission. Means we have to create one list. For what? Virtual mission means that we have to create one list. What is the ID? What is the virtual mission ID? What is the MIPS? What is the size? What is the RAM? We have to create so that in that virtual mission, we have to add a list of these things. And we have to create one broker. Means in that broker, we have to create one cloudlet on it. Means we have to know what is the file size, what is the output size, what is the length of the file, what is the cloudlet ID, and then the broker will be started the process. Once it completed, it will show the broker will be ended and the simulation will be started, and if there is no errors, it will show the simulation will be completed. So once we can run the program, we have a clear idea on it. These are the examples. Now we can run one example to see the output. Yeah, here we can see that first the initialization will be started and the data center will be created, and in that data center the broker will be started. So in virtual missions will be added and then the broker will be shutting down, and the simulation will be started and will be show that simulation will be completed. What is the output is we have to what is the what is the cloudlet ID, what is the status of that, what is the data center ID, and what is the start time and what is the finish time. At last it will show that the file name will be finished. So